So during this short keynote, I have several tasks to accomplish. I need to tell you how complex the agricultural industry is. I need to tell you where our place as Bayer in digital farming at Bayer in this world, and I need to answer questions. And I want to show you a video as well. So everybody knowing me, they know pretty well I can tell you a joke about anything. But today I'm very serious, and I'm not going to tell you jokes. I want to tell you a real story. About 10 years ago, I had an argument with my boss at that time. So a few times during the conversation, he mentioned about the agricultural industry. You know, that's not the rocket science. Oh, that's not the rocket science. And eventually I blew up. I said, yes, it's not the rocket science at all. It's much more difficult than any kind of rocket science. Because in rocket science, we deal with many variables, with many constraints, but we can model them and we can address them. Dealing with Mother Nature, we deal with many unpredictable things that makes everything so unpredictable, difficult, and much more difficult than rocket science. And that's one of my first messages that I would like to deliver. Agriculture is always complex, very complex. It's regional and it's site-specific. Why it is regional? Because different countries, they have different crops. For example, in Canada, we have wheat, we have barley, we have canola, we have pulses. US has corn and soybeans. Brazil grows soybeans, corn, sugarcane. Europe grows winter wheat, oilseed rape, vegetables, fruits. So if you take all those differences, overlay it with climate differences, legislation, mentality, hardware, practices, that will be a huge difference between regions. So for that reason, it's very important to make sure that we collect, analyze the information about every region, every field, and we implement that in our crop production practices. So this is one of my favorite slides. I travel a lot around the world, and people collect different things. People collect stamps, coins, cigarettes, wines. I collect pictures of arable fields. So anywhere I travel, if I sit by the window on the plane, I try taking pictures. So in addition to regional variability, there is site-specific variability, within field variability. And that makes everything even more difficult. So anywhere in the world, the Netherlands, Canada, Ukraine, US, France, anywhere else, you take a picture of a field and you will see variability that will add more complexity to crop production. Also, one of my favorite slides. Of course, most of you know what yield monitoring is. So what kind of yield variability range can we expect in one field in percent? 10% between different areas, 20, 30, 40, what do you think? More than 40. 29-acre cornfield in Kentucky, US, 4-meter elevation range. After the information was cleaned up, we had 500% yield range. So that means huge variability between different parts within a small piece of land. So that means it's extremely important to collect and analyze and utilize this information for any piece of that land. That's where the whole idea of digital farming coming from. However, I showed that slide to one of the Canadian groups of farmers, and one of the guys was sitting on the front row. Oh, he said, that's a bad American field. You show us a good Canadian one. Sure, no problem. That field, 1/4 section, 160 acres, located in western Manitoba, looks pretty flat. It just slopes from one side to another, 8-meter elevation range. Over 1,000% of difference. It's huge. And of course, it adds more complexity to what we're doing. So what exactly does the agricultural industry expect from us? if we take all different applications offered on the precision ag market, they can be divided into 3 different categories: sense, decide, and act. However, most of them, they're located in this category, sense. That means collecting imagery, looking at pictures, looking at charts, tables, and things like that. A little bit less are focused on decision making, and almost nothing comes to actual action, deploying, implementation. But that's what the industry is expecting from us. They expect the action, and they expect everything to be done in a very simple way. So that complexity that we were just talking about, we just need to automate that and present in a very simple way, which is extremely difficult task. So for now, instead of having that easy button, we have not an easy button. Just to give you an example, 10, 15 years ago, AutoSteer picked up exponentially like that. Why? Because it was sensing, meaning determining the position of field equipment in the field. It was deciding how to drive in the field, and it was acting, meaning you didn't have anything to do. You just install it and enjoy it. Variable rate technology is a great tool that helps to improve the quality of agricultural practices. However, it's still struggling to show return on investment, struggling to convince farmers to use that technology. And the main reason for that, because first of all, the grower needs to learn basics, then needs to hire a consultant, needs to collect soil samples, needs to sit down with the consultant and figure out how to make it work, needs to make sure that there's the hardware in place, field equipment in place, everything is talking to each other. So it's additional work, and that's not what the industry is looking for. Everybody is looking for that red easy button. Another interesting topic is about collaboration. I was pretty happy yesterday to hear from one of the participants in the panel discussion. It was about everybody having a piece of a puzzle. Everybody has a piece of a puzzle. Like, using an analogy from the IT industry, there are several platforms: Windows, Mac operating system, Android, Linux. So those platforms, they compete with each other. At the same time, there's a whole bunch of different apps. They work on any platform you can think of. So Facebook can run on the cell phone, it can run on Windows, or you can take Skype and integrate your contact list with a Google app. So those apps, they talk to each other. And that's, I strongly believe that that's exactly what the industry is expecting from us. They don't expect a holistic platform that will do everything. That platform doesn't exist, and I don't believe it will show up anywhere on the horizon in the next few years. But I strongly believe in many valuable apps that will help the industry, will make it more efficient, and will make it easy compared to what we have now. So where is our place? Bayer Crop Science. For us, digital farming program is relatively new, but we're developing pretty quickly and efficiently. So in 2017 and 18, we're at the stage when we're testing certain applications on 100 farms in different markets, including Canada, European countries, and Brazil. So those solutions include Digital Farming Field Manager. It's a tool for site-specific applications, application of crop protection chemicals. Scouting, that's a tool for utilizing mobile phone technology for field scouting. And Digital Farming Timing, that's a tool that utilizes weather information, disease, insect, weed modeling for right timing for the application of crop protection. So to be able to implement those tools, we're widely relying on remote sensing tools. So why remote sensing is so important? Mainly because of the scalability. because the capability of remote sensing to collect the information is huge. We're talking about hours to collect one high-resolution drone image, or days and years to collect reliable yield data. With remote sensing, we can cover huge areas within a few seconds. Just that example is a satellite image from DMC-II with very wide swath, 22-meter resolution, 300 kilometers across the sea. So that means that scene can cover about 100,000 Canadian fields in just one snapshot. And for each of those fields, we can extract the information and convert that information into certain valuable thing that can be used for action in the field. So in this particular case, we see that this field is quite variable. There is a variability in grain biomass. And of course, if we have different leaf area in different parts of the field, it will require different strategies on fertilization, seeding, and of course, application of crop protection. In addition to remote sensing, we're heavily investing in image recognition technology. And that's not fantastic. That's something either we're already testing or it's pretty close down the pipeline. For example, weed scouting is a tool based on image recognition technology. You know, if anybody of you did the field work and tried to identify seedlings of weeds, it can be challenging even for experienced agronomists. So very easy. Now, you take the picture and the system tells you what kind of weed you have. And of course, you will be able to decide how to control that weed and how to avoid the resistance. Another thing, leaf damage detection. Flea beetle damage in canola, for example. It's very important to have that information because depending on the actual percentage of the damage, we decide on spray or not to spray the field. And by taking a simple picture in several places in the field, we're able to tell right away, okay, 4%, there is no need to spray. 6%, for example, there is a need to go ahead and spray and control the pest. Another thing that we're working on is RFID tagging. That's another important thing. It's one of the pilots that we tested last year. So we basically placed RFID tags on our seed packages. And that gives great opportunities for us when the package passes through that RFID scanner. It triggers a whole bunch of different things. We know the package left the warehouse. The information is connected to our inventory, and it can trigger a whole bunch of different alerts and actions. And one more thing, I was asked to provide a couple of case studies. I just would like to share just a couple of things. One thing is about site-specific application of herbicides in Brazil, and one is about spraying fungicides in Canada on canola. So in Brazil, what we did, we're right now testing that on a large number of farms, because you know, based on the concept of field variability that we're talking about, everything is variable, including weed distribution across the field. So between the growing seasons, we can take imagery, either using drones or airplanes or satellites, and we can identify areas where weeds are located and that are really needed to be sprayed. So instead of spraying the whole field, it will be just certain parts of the field sprayed, and that will give certain savings on the one hand side, and at the same time, on the other hand side, it will give the farmer increased efficiency of his field operations. Another case study, that's zone spray in canola, because same thing, if you look at that field, you'll see different patches with high vegetation, low vegetation, and virtually no vegetation. Unfortunately, in many places in the North American prairies, we don't have that luxury of California where all the fields are flat like a table and you don't see that variability. So, there's an interesting part. by regulations, crop protection chemicals needs to be applied within a certain label rate or has to be not applied at all. So how do we utilize the current technology and make sure we comply with the regulation? It's not like variable rate fertilization when we can apply anything from 0 rate to whatever will burn the crop. So in that case, we just make sure that we apply crop protection where it is needed, where the risk of disease is higher than average, and when there is no return on investment and there is no risk of disease, the sprayer will be turned off. Unfortunately, the time is short, so I just want to quote our CEO, Liam Condon. For us, digital farming is not just a tool to improve the efficiency of our crop protection or something just to provide agronomic advice. It's about changing our vision of the agricultural practices towards selling the outcomes. So instead of selling just crop protection, we can sell weed-free fields or disease-free fields. And that's something that we're testing today and we're going to offer tomorrow. That's everything I wanted to share. Just wanted to give you some tests, and probably my assumption would be you have even more questions than you had before. I will be around and we'll be more than happy to have a chat with you offline. Just please feel free to find me. Otherwise, thanks so much.